Imagine a robot so advanced that it only requires a single artificial intelligence model to flawlessly mimic human-like movements. Sounds like science fiction? Well, this is exactly what Boston Dynamics' humanoid robot, Atlas, is showcasing now. And it's changing the way we think about robotic learning and control. But here's where it gets controversial. Unlike most robots that use separate AI systems for walking and manipulating objects, Atlas has mastered both with one unified model, and it's beginning to show surprising, untrained behaviors. Atlas, widely known for its impressive parkour and dance routines that wow audiences online, has recently demonstrated a new, much subtler feat, walking and grasping objects seamlessly using one AI framework. Even more fascinating, this single AI system has developed what researchers call emergent behaviors, such as instinctively crouching down and retrieving something it accidentally drops, a skill it wasn't explicitly taught. This sparks an important question. How much of robotic skill can be learned autonomously versus pre-programmed? The brains behind this innovation are Boston Dynamics and the Toyota Research Institute, TRI. Together, they created a versatile AI model that learns to operate both Atlas's arms and legs by studying diverse example tasks. Typically, robots rely on distinct AI modules, one specialized in locomotion and another in object manipulation. But here, the robot treats its feet similarly to additional hands, integrating motion and grasping control within one system. As Russ Tedrake, the roboticist spearheading this project, puts it, the feet are just like extra hands to the model. And it actually works, which is just fantastic. Here's how it functions in more detail. The AI is fed visual input from Atlas's cameras, proprioceptive data, which lets it sense the position and movements of its own body, and language commands aligned with different tasks. The model learns by reviewing examples from teleoperation, computer simulations, and real demonstration videos. This amalgamated learning forms what's known as a large behavior model, LBM, which directs the robot to move and interact with the environment more naturally. For instance, when reaching into a bin to grab something, Atlas strategically moves its legs to maintain balance, very much like a human would. This ability to blend multiple skills in one cognitive framework is thrilling for roboticists because it mirrors the unexpected capabilities seen in large language models, LLMs, like ChatGPT. Just as language models surprise us by generating code or solving puzzles without explicit training, the hope is that these multi-skill robot models will autonomously develop a remarkable range of useful behaviors, adapting on the fly to complex real-world scenarios. Tedrake and his team are already testing this approach on various robot arms trained to perform household chores, such as cutting vegetables or cleaning up spilled coffee beans. The progress suggests we may soon see robots that not only handle multiple tasks, but do so with flexibility and speed akin to human learning. However, it's not all straightforward. As tempting as it is to celebrate these breakthroughs as robotic leaps mirroring the AI revolution in language, experts urge caution. Ken Goldberg, a roboticist from UC Berkeley, acknowledges the significance of coordinating arms and legs, but advises skepticism about calling these behaviors truly emergent. He notes a key point. Sometimes what looks like a new ability is simply a reflection of patterns seen frequently in the training data. That's why transparency about how often robots succeed versus fail in experiments is crucial. Fortunately, TRI has a track record of open sharing, and we can expect more detailed data about these LBMs soon. This raises a broader debate in robotics. Will simply scaling up training data unlock increasingly sophisticated robotic behaviors, or will engineering ingenuity and better algorithms remain essential? At a major robotics conference earlier this year, experts highlighted that while data is important, the future of robotics depends on a blend of creativity and smart designs. Tedrake is optimistic, viewing this moment as an inflection point. He believes we are on the cusp of deploying humanoid robots that can tackle messy, unpredictable environments and rapidly pick up new skills, from industrial tasks like welding pipes to everyday actions like brewing coffee, without needing extensive reprogramming. We need to get these robots out into the world and start letting them do real work, he says. So what do you make of Atlas's new abilities? Are we on the verge of a ChatGPT-style breakthrough in robotics? Or is the hype running ahead of reality? Share your thoughts. Do you see a future where robots learn and adapt as effortlessly as we do? Or should we temper our expectations? The conversation is just beginning.